Hello, everybody, and thanks for joining. My name is Erik Felt, and I'm the Market Development Director for Future Grid Activities for Real-Time Innovations, or RTI for short. I'm going to spend a few minutes talking about our Connex DDS, or Connex Data Distribution Service product, give you a quick overview, and then a quick working demonstration of what the technology looks like and how it would be a benefit for you. DDS is an open standard product that is owned and maintained by the Object Management Group. You can take a look at this link at the OMG website for more information. The OMG standard ensures a couple of different things for the market. Number one is that there's no vendor lock-in. Being an open standard, it's not a proprietary technology. There's numerous vendors and suppliers of DDS technology to the market. It also means that DDS suppliers are held to strict interoperability requirements, and security is also defined. We'll get into that in a second. A couple of key takeaways is that there's no lock-in with hardware or software or operating system or network type or anything else. DDS is indifferent to all of those. The biggest difference with DDS when you're looking at where it fits into optimization and control systems is that in today's world, we have a very centralized model where we collect device information from devices in the field. We bring those into a server or data center someplace, unpack those files, process the information, and then store it in a database. And then once it's stored, it becomes liquidated or federated, and we can have APIs and web services and such to get at that individual data. A quick example, we'll use frequency as the example. Let's say we have a generator someplace and we want frequency. We move that whole file from the device all the way back to a server. We unpack it, we store it as frequency, and now we can have frequency. On the flip side, with DDS, we create something called a data bus. And the data bus is a virtual environment where anything that's connected as a DDS user or a DDS participant can share information. Think of it as having device 1, device 2, and device 3, all of them being DDS equipped and enabled. And when they're connected to the data bus, it's as if they're connected to the same shared memory. Now this can be up to and include cloud environments, and again, operates over any type of network with scalability and resilience, reliability and security, and all sorts of other great words. The big important thing to take away from this picture is that there is no server required. There are no brokers, there are no servers, there are no single points of failure. So it creates a very fast, reliable, and fault-tolerant environment. Another big point is scalability, and when we look at the worlds that these new autonomous systems fit into, there's really no limit to the scale that's going to be going on out there, and DDS is a tremendous fit for that because we can layer and create additional layers of information as it's shown in here. Obviously, information that's pertinent to a microgrid is important to be shared with other participants on that microgrid, but it may not mean something to a device inside the substation. So pertinent information stays on that data bus. Relevant things are routed off and placed where they need to be. And that's up to and including cloud environments. So there really is no restriction on where that data is going to have to go. DDS fits on top of the OSI 7-layer stack. This is what that looks like. And really this is called the Industrial Internet Consortia's connectivity stack. It's 9 layers instead of 7 because we needed another layer for that additional ability to stream data, events, and look at states and so forth. Truly, this is the interoperability piece of it. And again, indifferent to network, hardware, software, and all of those other things. I mentioned already that it can operate on any type of memory, or excuse me, any type of network that includes serial and shared memory, and it's equally at home on UDP or TCP environments. So a couple of the big benefits: very low latency, really at wire speed of the network, very high throughput, scalability, and security. We could spend a lot of time on security alone. The takeaway is that DDS does not replace any of the security in place. It really augments everything that's there. Okay, jumping over to a quick demo of what the technology looks like. First thing I want to do is show what it is. Our demonstration today is something that I call autonomous load management. And it's an environment where we have 4 chargers, EV chargers, or electric vehicle chargers, connected to a data bus. We have a building load, which is variable but not controllable. Think of your house, you know, you've got variable load, but it's not necessarily controllable. We have one instance of a solar panel array, and we have some batteries for storage and an inverter. And then we have the ability to go in and collect user inputs. The users can say, I want the fastest charge at whatever price. I want a partial charge because I just have to get home, but I only want to pay X amount for it. I want low cost, or I'll take energy from the grid if it's cheaper than my sunk cost into the solar panels. So a couple of simple scenarios, but they have some importance I'll talk about in a second. The other important thing here is that we can take an input from a disparate system, be it an existing utility system or some other control system. We publish that number to the data bus, and then the devices, again, you don't see a server in here anyplace, the devices communicate with each other and don't exceed that threshold. One other quick one that's on here is a load as a resource, and that resource means that we can protect the grid from having reverse power flow or things going back onto the grid. And I'll show that in more detail in just a second. This is our user interface. It's quite simple. It's made with LabVIEW. LabVIEW has DDS already installed in it, so it's a great tool for that. Not a control system, just a means of graphing things. So a couple of things to show very quickly. I am connected to this board. This board has 4 green lights. Those are the electric vehicle chargers. I have a solar panel here. That's our solar farm. Excuse me. Here's my rechargeable batteries. We have a virtual inverter. Obviously, we didn't build an inverter for that. We have a small fan down here, and that's my load, and then a potentiometer that lets me speed up and slow down the amount of load that goes in, and you can see that value changing in the graph down here. And then another couple of important pieces. I have the sun, power of the sun in my hand. And I have a couple of batteries, which are the electric vehicles. And the electric vehicles are what we'll plug into the EV chargers. So first and foremost, right now we're starting out with a 10 kW load. So we've got these 4 chargers, again, 60 kilowatt, 7.2, 3.6, or 0 kilowatt on these 2. And then this is just a simple outlet, which I won't be using. I'm going to focus on these 2 because of our short amount of time. Right now you can see that we've got very low energy coming out of our storage system, and we have very low output from our solar system. But keep an eye down here. This is our overall, this is our whole system usage. And if the sun comes out, again, my flashlight, and that goes over my solar panel, you can see that jumps up. So right now we have low usage, about 5 kW. We have high output from our solar, about 15 kW, and you can see as I move that moves around too. And you can see our net difference is we're producing more energy than we're using. So we're pushing energy back onto the grid right now. I'm going to go ahead and change this number to 70 kW and publish that. You can see our number goes up to 70 kW total. And along comes our first electric vehicle with a fast charger, and it plugs in and it's at 60 kW. It's taking full charge, they're paying a high amount, they're in a big rush to get someplace. The takeaway from this is that right now we're less than the 70 kW threshold, so we have no problems. And if the sun comes out and we've got 15 kW of electricity going back into that localized network, you can see there's no problems at all. If my building usage ramps up and the sun goes away, you can see we flatline at 70 kW. What's happening right now is this device is acting as a controller. It's talking to all of the other devices on the system and saying, when we come up close to that 70 kW limit, I'm going to bump down and take just a little bit less. And if I cover up the solar panel, you can see that my value right here is what changes. It goes from 80 to 81, 82, 83, something like that based on the available usage. So what happens if user 2 comes along? And I had told you that we could have multiple inputs, fastest, partial, etc. Really what these are doing is assigning a hierarchy in the way that these devices are participating with each other. So I'll plug in electric vehicle 2. You can see that turns on. And because this is now a subordinate to this one, it's taking 0. We did not have enough excess energy here for this one to be able to take anything on. The load on the building takes priority. And if my building load goes down, you'll see this light start to flash because now this level 2 charger, which can operate at 0, 3.6, or 7.2 kW, sees the opportunity where it can take a 3.6 kW load, so it's filling that part in. If that building load drops further and the sun comes out, you can see that one pops up and goes higher. If we have these reversed, same type of thing happens, but in this case, this becomes the controller, this becomes a subordinate. This one goes to 7.2 full load, this one is taking the variation. But again, we're not exceeding that 50K or that 70 kW limit. If I change that limit and move it down, same thing holds true, except the interesting thing here is that my level 3 charger, or my variable charger, is the one that's doing all of the jumping around, but we're not exceeding that 50 kW slot. I can change that time and make it go up by ramping up my building load, and I can make it go down by ramping down my building load as well. One other quick example here is I'm going to put these both into a do not charge state. It means that they're connected, but they're not accepting any charge right now. And if you recall from when I first started talking about this, we had a low value in here. We had a low building usage, and we had a low solar input until we had the sun come out. And when the sun came out, we had high output from that, but low usage, so we were pushing energy back onto the grid. With a DDS environment like this, it's very easy to come in and say, create a load as a resource, and look what happens. This jumps up and starts taking all of that excess load, and we're no longer pushing energy back onto the grid. It's a very simple example, but it's a very easy way of highlighting that difference, that we see the grid of the future as being one where it's not important to only turn off loads, but then also create and add to, so that we can take away peaks and valleys in the way that the system operates and really deliver a flat line. All of this is very easy to show in a product that we bring to market. It's called Administrative Console. It's our ability to connect to and see everything that's going on within that environment. So if I click on any one of these different devices or device types, I can see everything that's there. I can also go into great detail on these and look at individual values and even chart out what's going on. As an example, right now I'm on my solar panel, and you can see when I put the sun back on my solar panel, that value goes up and down. So we're able to see that real-time information live and up close with great detail on the Administrative Console. One last takeaway on this is that even with the Administrative Console, we can also see if we have things that are not authorized to be out there, or we can see everything that's there. That's part of something called discovery. And just as a quick example, I'm going to come over here and turn on our demo system. You'll watch over here and see that light up when that starts. And just like that, the admin console recognizes that something's been added to the system. It knows what it is, it knows who it is and everything else, but there's nothing going on with it, so it's healthy and happy. But if we do something that the admin console does not expect, for example, we try to subscribe to information that doesn't exist, it's intuitive enough to tell us that right now I have something that's trying to read information or subscribe to information that doesn't exist. All of this and more is available anytime. I'll put up contact information here. Please feel free to take a shot of this or download the information as it's available and reach out to us, and we'd be happy to discuss further. Thanks for your time and attention. I hope this gave you a brief overview. And again, please don't hesitate to reach out if we can ever be of assistance. Thanks.